looking at identifying transformations. Okay? For each transformation activity, the type of transformation that was used, use constructions to prove the transformation and identify those pieces from the list below. When you are finished with the construction generalization, how the missing pieces can always be found given the image and the pre-image. The bold triangle is the pre-image. That's what you start with. So the bold one is the one you start with. For a translation, you're going to identify the vector, like what direction and how far it went, the length. A rotation, you're going to identify the center of rotation and the degree, the magnitude. For a dilation, you're going to find the center of the dilation and the scale factor. And for a reflection, you're going to find the line of reflection. So we have to say if it's one of these four and then these other pieces to it. You guys ready to get started? Okay. So I'm looking right here at number 1. This is the original triangle, and it came to be this. What do we think happened? We think it's a reflection. Okay, that's good. Okay, so the first thing I'm going to do to figure out where my line of reflection is I'm going to pull my ruler out. And some of you have a ruler on the end of your protractor. But I'm going to draw a straight line between B and what I consider to be B image, right? Do you guys agree that my line of reflection is going to have to go right down the middle of these? Right in the middle? So I can look at my ruler and I can say, okay, this is 5 centimeters, so in the middle would be 2.5. So I can then draw, that is, and I'm going to label it my line of reflection. How are we doing? Yep, I can. So I measured, if we cannot stop talking, we will be moved back to our assigned seats. This is the final warning. This is 5 centimeters from B to B. I'm going to just write this down. B to B image is 5 centimeters. The line of reflection is in the middle. Okay. You could have done this for A to A as well. And you could do it for C to C as well. It should be right in between all of those. Question about doing reflection and line of reflection. Okay, let's turn it over. All right. Now remember, I can choose from a translation, a reflection, a rotation, or a dilation. We're looking here. We've got A, B, and C. This is my B image, my A image, and my C image. How would I get there? What do you think? Translation, reflection, rotation, dilation? I think it's a rotation too. Okay, so for a rotation, remember we have to find 2 things. The center of rotation and how many degrees happened. So what I'm going to do is I'm going to connect B to B, A to A, and C to C. So you want to make it as accurate as possible. Okay, so right here, where those meet, that's my center. Okay, now this is where it gets weird. When we do a rotation, we have to find the angle of rotation. So I find this harder to do. So what I'm going to do is I'm going to increase line A to B and line A prime to B prime until they meet. So I'm taking a different color so you guys can see this. You do not have to use a different color. And I am just making these two angles, these two lines, until they touch. Does that make sense what I did?
Yeah.
I increased A to B and I just drew a line out. And I increased A prime to B prime and just drew that line out. I could have done B to C and gotten the same thing. It's just B to C, it's kind of like it would be down here and it's easier for me to show. So any of the lines, if you increased until they touch, this would work. Now I'm going to take my protractor and I'm going to find the measure of this angle, and that's going to tell me. Do we have any guesses? How much did I have to rotate from here to here to get the answer? What do we think around that center? Okay. And I'm going to take a piece of patty paper to kind of prove it to you when I'm done. Okay, so if we measure this angle right here, we get just right about 70 degrees. So I think it was a 70-degree rotation. So what I'm going to do is I'm going to trace this original triangle. Nope. I'm going to label it A, B, and C. The reason I'm doing this is because I want you to see. Okay? That's my center. We're rotating it. My center's, it's really hard to do this on here, but it'll hit here. But if I rotate it 70 degrees, I get it. This is really hard to do. So my rotation is 70 degrees. That's my center. Okay. Let's move on to number 3. And you guys can tell me what you think it is. What do you think happens to go from A, B, C to, let's see, this would be A prime, B prime, C prime. It is only one thing. It's a dilation. So a lot of you think it's more than one thing because it looks like it was like reflected or something. Okay? So what we're going to do is we're going to draw from A to A prime, B to B prime, and C to C prime. A to A prime, B to B, and C to C. How did you guys recognize so easily that this was a dilation? What happened? It changed size, right? If it changes size, it's got to be a dilation. So for dilation, we have to talk about our center of dilation, which is right here. That's my center of dilation where they all intersect. So I want you guys to notice something from your packet yesterday. When we did a negative dilation, it looked like it rotated. So B is right here at the top. Now this is D. So this is going to have to be a negative rotation, dilation. That's the word I'm looking for. This has got to be a negative dilation because it changed. C moved to the top from the bottom. Okay, so first we found our center. Now we need to talk about our scale factor. Okay. What is my scale factor for this? How would I figure that out? So let's measure the sides. Let's do B to C. B to C is 5. What do we think C prime to B prime is going to be? 2.5. So the scale factor is going to be what? What's 5 divided by 2.5? Or the other way around. 2.5 divided by 5, right? It's 1/2. And it's in the negative direction because it went down and to the left and it rotated or reflected. Okay. Number 4, I'm going to tell you right now, is a bit tricky. What do we think happened to get from B, A, and C? What happened? It's got to be a rotation. Okay. So, but the center of rotation is going to be in the middle. So it's going to be a little bit harder to do. What do we think number 5 is going to be? Let's try that again. It's going to be a reflection. What do we think number 6 is going to be? Dilation. Okay, and we're going to do number 7. Okay, I am going to connect B to where I think B prime is, A to A prime, C to C. What do we think is happening here? Is this a dilation, reflection, rotation, translation? It's a translation. And my translation went from here to here. That's my vector. How long is that? How far did it go over? Just gonna measure. How much did you guys get when you measured? A to A is how much? B to B, C to C. They should all be the same. 5 centimeters. That's it. Okay, so you have 3 to try on your own. 3 to try on your own. Okay. Tonight's homework. Simplifying, we've got an example right here. A squared plus 7a plus 5 over a equals a squared plus 7a over 5. So you're just doing it over each one and then reducing it. So if we did number 1, we have x to the 3rd over x plus 2x over x. That reduces to x squared plus 2. Okay? Because remember, we're subtracting. 3 minus 1 is 2. 1 minus 1 is 0, so we can just leave it right here. All right, that's it. You have the rest of the hour to work on this. I recommend doing the identifying transformations first.